Welcome, and thank you very much for participating in today's Solar Decathlon virtual session, which will address discovering clean energy careers. My name is Jonathan Cohen, and I work on the Solar Decathlon, as well as run the Better Buildings Residential Network with your Department of Energy. We strongly encourage you to ask the questions you want answers to on today's virtual session. That is why we are here. And we are going to have all sorts of opportunities to hear from people who have made careers in this great field of ours, and we'll share their story and give you a chance to ask them questions and learn more so you can plan your own career. We also want to encourage people on this call who are students to apply today for the Solar Decathlon's 2021 Design Challenge in order to get in under the deadline of October 20th. Just go to solardecathlon.gov for more information. And we also want to note that the views of speakers on today's virtual session are their own, do not reflect those of the Department of Energy. And a summary of this virtual session will be posted in a few weeks afterward and include the speaker PowerPoints. Just go to solardecathlon.gov to find links to all of our social media, including our YouTube channel for the recording. And now we're going to go on to the next slide, and we are going to share with you what today's agenda looks like. We're briefly going to share that we have a whole plethora of upcoming Solar Decathlon virtual sessions. We're going to share where everybody is on today's call in terms of maps. You can see what the representation is. We're going to have an opening poll because we want to engage you early in today's session. Then we're going to have three stellar featured speakers who each have a tremendous story to share about how they got into the clean energy field. And then we'll have an opportunity for everybody on the call to ask them questions. Then we'll have a few wrap-up announcements. So we're going to go to the next slide, and we're going to share the schedule for our virtual sessions. We're doing one a month through May, and they're all around the middle of the month. The next one will be Wednesday, November 18th, and it will be a virtual hands-on energy workshop for families, in which case we will also be in touch with everybody who registers to encourage participants to have a few materials with them in order to make the most of the session. Then we will have a student showcase in December, and then in January, we will feature a solar legend in the field who will talk about Resilient Home 411, strategies to weather and recover from natural disasters. And then in February, we will cover Zero Energy Ready Homes, new and growing fast. And then in March, the Future of Solar, a tour of cutting-edge solar research with the Department of Energy. And then in April, when the actual Solar Decathlon Build Challenge, as opposed to the Design Challenge, so we'll actually build homes, we're going to take a tour of those homes. And then in May, we will have a session with the winning home from the Solar Decathlon Build Challenge. So next slide, please. And now we want to show you where all of you are. You are scattered all across this great country of ours, and we are really pleased with the breadth and the spread of all of the participants. So we want to thank you all for being with us today, and we always find it's helpful just to get a visual sense of where everybody is. Next slide, please. And now we want to actually engage you, the participant, in our opening poll to get a sense of which best describes your role or occupation. Please select one of the following options on the screen, and we will give you a little bit of time to vote and then come back with the results in real time. Okay, I think this is a pretty straightforward question. People probably have had enough time to answer. And so we will check the results, and they are in 45% of you are students. A large 23% are in other, and my colleague Tyler might share with us a few of those if people have chatted in. 15% are energy efficiency professionals, 13% are homeowners, and 5% are solar professionals. So a very nice array of responses to our opening question. We're going to move on in our presentation today. And after that poll, we are going to move on to our first speaker. And we are extremely pleased to have with us today Bill Edgar, who serves as the energy manager for the city of Alexandria in Virginia, where he leads the city's multidisciplinary Office of Energy Management team. And as energy manager, Bill pretty much does it all. He leads planning, engineering, programming, technical evaluation, policy development, education and outreach, and implementation of Alexandria's energy efficiency, clean energy, green building, climate change mitigation and adaptation, as well as resilience and related sustainability initiatives. In addition, Bill leads Alexandria's response to energy emergencies, as well as greenhouse gas emission reduction planning, and Bill leads various smart cities strategic planning initiatives on behalf of the city of Alexandria. He has a tremendous array of responsibilities, and we're looking forward to hearing him talk more about what he does and how he got there. Bill, the floor is yours.
Good afternoon, everybody. At least if you're on the East Coast, and for my friends out West, good morning. Glad to be able to speak to you today about preparing for a clean energy career and give you a little bit of my story of how I arrived to serve as the energy manager for the city of Alexandria, and offer some thoughts on how you might want to consider your own career trajectory in the clean energy field. Next slide, please. So what I'll share is a little bit of my background, give you just a little bit of context for my story. Hopefully, some of my story will resonate with many on the line. Talk a little bit about how I prepared for my career in a clean energy field. Talk a little bit about my kind of what my day-to-day looks like as an energy manager serving the public in the context of a local government. Give a little bit of insight into what I love about my job, why it's important to me, and what helps me thrive on a daily basis. And then, looking back in reflection, offer up some thoughts on what I would tell my younger self, either what I did right or what I did wrong, such that as I prepared for and continue to prepare myself for my clean energy career, what you might be able to take away as well. Next slide. So where I come from, just to kind of give you a little bit of relation to who I am. Born and raised in Dayton, Ohio, in the heartland and Midwest. Went on to receive and earn a Bachelor of Science in Computer Engineering, a Bachelor of Science in Electrical Engineering, and then ultimately a Master's of Science in Mechanical Engineering from the University of Dayton. Also currently pursuing a Master's in Sustainable Urban Planning, which is relevant to a lot of the work I do in a city context. I've put a number of photos here that just kind of, we've talked about preparation for a clean energy career. I think it's important to note that our life experiences, set the tone for whatever career path one may choose, and mine had influenced in many ways, some in more explicit ways than others, but ultimately preparing me for kind of the career path I've chosen to pursue meaningful work in clean energy and climate change action. Everything from early age, being in the Boy Scout program and learning about the outdoors, responsibility, and ultimately achieving the rank of Eagle Scout, or to being in the marching band and having kind of a really superior mentor as a band director who really set me on a course, just helping me understand kind of what's important to me and what I might want to pursue in college. And ultimately, and ironically enough, having played rugby in college was also a really eye-opening opportunity for a clean energy career, and really by interesting circumstances of exposing me to new cultures, and many of the people I met with in the rugby team actually exposed me to kind of international issues and social justice issues and the like. So it was really just a formative experience for me. Just kind of, and these are just a snapshot of a few items, but certainly meaningful ones along my pathway. Next, please. From a career perspective, parlaying, I had the opportunity after kind of really some formative experiences in college, really looking to international travel and leveraging my engineering degrees accordingly, and ended up landed in Nicaragua and was working as a solar developer for some rural solar and community development opportunities. But ultimately, that led me to kind of more of the most foundational experience of my clean energy career, and that was to serve within the ranks of the University of Dayton Industrial Assessment Center. If anybody's aware, the Industrial Assessment Center is a program facilitated at the U.S. Department of Energy, scattered across 30 different universities, that really is a training ground for the next generation of energy engineers, putting graduate students and undergraduate students in the context of learning how to do energy audits, learning how to approach industrial energy efficiency, and look at how the incidence of energy use in industry is actually, has a really profound effect on the overall kind of energy systems within our United States and the world. From there, just talk a little bit, moved on, was a short time as a consultant, and then ultimately moved into public service, ultimately current working as an energy manager for the city of Alexandria. I put here a couple pictures just showing kind of some experiences along the way. On the left-hand side there, serving the city of Cleveland, had the opportunity to work on some wind projects out in Lake Erie. Center there is a picture from Nicaragua, having worked on with some local communities on siting some solar foundations, et cetera, and then ultimately working at the Industrial Assessment Center there on the right, within the context, I believe that was a steel smelting facility that was working in. Next slide, please. What I wanted to just, those are all kind of really set the foundation, but here, just offer some thoughts on preparing for a clean energy career. And that's really being kind of solid in your fundamentals. And what I mean by that is, for me, it was in the Industrial Assessment Center. I really went back and in graduate studies really worked to understand foundational engineering principles, from thermodynamics to heat transfer to fluid dynamics. And these are just from the scientific perspective of the clean energy space. But ultimately, those for me were, whether you're coming from a policy perspective or engineering and science, really understanding and diving deep into the fundamentals is important. Secondly, is broaden and connect to your fundamentals knowledge. I had the opportunity to take a lot of additional coursework, and have since taken a lot of additional coursework in adjacent topics, be it in the economic sciences, be it in geographic information systems, be it in data science, be it in public health, et cetera. But in so doing, and taking a broader approach to the energy conversation and clean energy conversation, really been able to kind of understand clean energy and the clean energy sector, so to speak, from a variety of different dimensions, and look to connect that back to the fundamentals knowledge that, again, I spoke to as kind of honing. Also, kind of from preparation perspective, it's like looking at 30 years in the future and working backwards of what are the opportunities. Certainly, we can look to the future and know that clean energy will be a significant portion of our overall energy portfolio. And as we, between now and then, transition and decarbonize our energy systems, it will only become more important. So I encourage, from a preparation perspective, to really look for what are the technologies, what are the circumstances beyond just, say, solar or otherwise, that will manifest themselves in 30 years out, insofar as we know them, and start to build yourself a career that kind of looks and follows and tracks that pathway, such that there's opportunities all along the way. It doesn't have to be just in the solar space. It could be, say, in grid infrastructure, or policy and planning, or urban planning issues, or green building design. The breadth of opportunities are tremendous. I think also for me, and what's extraordinarily important in preparation for a clean energy career, is knowing my why and connecting that to my personal values. I believe in environmental justice. I believe in social benefits. I believe in a lot of different non-technical elements of the clean energy transition and clean energy career. And I always have kept me rooted in what are my central why as to why I'm pursuing this career. It keeps me motivated and keeps me working towards it. And sometimes when the clean energy fields can be challenging from a policy perspective, or just at the pace for which it takes form. Next slide, please. Talk a little bit of the day in the life. Frankly, it's a really challenging thing for me to offer you a typical day. I was looking back over my calendar from the past 2 weeks, and frankly, there was no day that was ever the same. One day I was working on energy efficiency projects for one specific facility within our city's portfolio of buildings, then working on a strategy development for how our community will approach pervasive electric vehicle charging infrastructure to support our community members as they advance electric vehicles in their own households and industries and businesses. Presentations to Planning Commission on how we were to approach modeling carbon impacts, new developments. To the next day, working on a complex tax incentive structure for a new program we're rolling out to support energy efficiency for our commercial properties. We're rolling out and have been finishing up a program for our battery electric bus program and installing charging infrastructure to frankly, working on greenhouse gas inventories and climate change adaptation programming and planning. This is all to say that the diversity and breadth of the work we do, and I do on a daily basis, really covers all of the kind of clean energy, so to speak, elements that an individual organization, again, the City of Alexandria, or on behalf of our community as a whole, might address or might come into contact with with regards to the broader energy systems. And so if you go to the next slide, please. This is to say, what do I love about my job? And I think it is just that. I think the unique opportunity of working in a city or the context of kind of leading energy and climate action programs for a city offers the breadth of addressing really the multitude of different ways that energy comes into contact with individuals at a kind of very localized level. And again, I spoke to some of the projects I'm working on, but frankly, you talk about electric vehicles, we're talking about solar, we're talking about energy analysis and energy audits and electric vehicles and state policy issues, working on national policy issues, and everything from planning to kind of educating our communities on the importance of the clean energy transition, climate change action, and everything in between really is kind of the kind of pleasure and privilege that I'm afforded working in the city, in a city context. I think what's also really important for me and why I love my job in this space and why I maintain a really clear focus on advancing clean energy within a local government or a community space is it really has tangible impact on the individuals that I come into contact with, the members of my community who I speak to on a daily basis. I know that the work I'm doing in working to transition our energy systems to a cleaner future has immediate and relevant impact, not only their day today, but their day tomorrow and into the future. Next slide, please. A couple things that I would tell myself. I think I did a lot of things right, learned a lot along the way and failed along the way in so many manners. But I think just some reflections that I think are helpful. Travel, and I think this is more important than ever. It may not seem like a kind of a relevant topic for clean energy, but what's important, I think, to take away is to learn about different cultures, learn about different approaches, learn about the impacts that clean energy transition has, both from the negative context or from what it can provide in the benefit or the positive context, and seeing how that impacts cultures not only locally, but also across the world, should that be an opportunity. I also think what I would tell myself is really to seek out mentors and ultimately also be a mentor. I think I had a great mentor as a band director when I was in high school, a great rugby coach in college, as well as a tremendous advisor in my graduate studies that all were really significant mentors in my life, and it set me forth on what I can now say is a really strategic arc towards engaging and participating in the clean energy careers. But also, I think there's a lot to say, as you move on in your careers, to continue to be a mentor to others, be it presenting to an audience like we are today, or working one-on-one with colleagues, or just even others, youth or college students or whomever who may have interest in a career path in the clean energy field, is to really to continue to be a mentor. I would also just really encourage, and I do myself, is really continual learning, and reading is the most, this is pretty fundamental. This isn't rocket science, but reading is the way to expose oneself to so many new ideas, and be it periodicals, be it journal articles, be it books, be it whatever that is meaningful, reliable, and kind of provides the context for learning, new information. I think reading is important, and also in just diverse fields. I pick up literature and everything from the business to econ to public health to environmental sciences to even sometimes dystopian futures for that matter, to really learn about what the possibilities are within how we approach our clean energy future. I would also just, continue to foster a resilient long-term mindset. I got to be honest with you that, the clean energy sector up until recently is palatial in its development and incremental. And I think we're seeing transition now as the effects of climate change are ever more present on a daily basis and ever more acute. But frankly, it takes a long-term and resilient mindset to understand that this stuff plays out over a long period of time, and to have the motivation to continue in this career will take kind of a resilience to continue on even when things are slow and not as dramatically changing as we would otherwise want. And I think finally, I would say, I think this is, again, I think clear for any career path, and that is allow your clean energy career to be fun. Have fun, and if it's not fun, find a new opportunity to pursue. I think I find my work fascinating. I think it's fun on a daily basis, and it keeps me motivated, kind of along with that long-term mindset that I previously mentioned. Next slide, please. With that said, there's my contact information, and look forward to any questions we have again, and I look forward to hearing from my colleagues.
Fantastic. Thank you very, very much, Bill. We really appreciate you sharing your story and how you got to this position in your career. And now, while we have Bill's presentation fresh in our mind, we are going to add to that, and we're going to go through all three speakers and then have time for your questions at the end. And so thank you again, Bill. And now we're going to move on to Amanda Kirkby, who is an energy engineer with the Applied Engineering Group in the Integrated Application Center at the National Renewable Energy Laboratory, affectionately known as NREL. And she is a major contributor to the Smart Labs Toolkit, drafting content to present straightforward, user-friendly guidelines and best practices for Smart Labs programs and high-performance lab design. Kirkby has a BA in physics from Middlebury College and was a member of the 2018 winning elementary school category design team in the Solar Decathlon Design Challenge competition. And with that, we're pleased to turn the floor over to Amanda. Amanda, over to you.
Hi, thank you, Jonathan, for the introduction, and really excited to be here today and share a little bit about my journey into clean energy career and share some lessons learned along the way. It was great to see Bill's presentation, and I think some similar lessons learned I'm going to share here, so that'll be good. But we'll start at the very beginning. Next slide, please. Back where I grew up. So I grew up in Mammoth Lakes, California. It's a small mountain town in the Sierra Nevada mountains of California, and I grew up skiing and biking and doing everything you could in the mountains, and as well as just a beautiful place, and really kind of inspired in me this mission to want to preserve those natural spaces. I also wanted to keep skiing in college and wanted to study some kind of engineering and go into renewable energy of some sort. I didn't know exactly what that looked like at all. But in order to ski in college, I had to go all the way across the country. Next slide, please. To Middlebury, Vermont, about as far away from California you could get. And I studied at Middlebury College. And it's a beautiful place in Middlebury, Vermont. Next slide, please. And my time at Middlebury was well spent. I think it was one of the best 4 years of my life, though I still I feel like every year gets better. but I studied physics, and I really took the liberal arts nature of Middlebury to heart and took about any course you could imagine, from environmental studies to architecture to art to film. Got involved. I have to include a picture of a cow here. There always has to be a cow in any talk about Vermont. But one of the most transformative experiences in that 4 years was an experience I came across actually through the physics department. And one of my friends, my junior year, had this idea, we should apply to compete in this student design building competition. And it was called Race to Zero then, but it's now called Solar Decathlon Design Challenge. And so we put a team together to design Middlebury Elementary. Next slide, please. And through that experience, it took us to Golden, Colorado, to NREL, and that was my first kind of exposure to what the clean energy career world could have been, and it was mind-blowing. This whole experience of designing a zero energy elementary school was eye-opening, and then going to Golden, getting the chance to tour the NREL factory, it was like being in Willy Wonka's chocolate factory, seeing the research that goes on there, and also just connecting with some of the industry professionals that were the jurors for the competition, as well as the workers at NREL, and also talking to students who are passionate about zero energy buildings. And I came out of that experience just fully fueled, and wow, I wanted to go into this for a career. So my senior year kind of, continued with physics, did a senior project, and by graduation, I hadn't had a job lined up or anything, and I didn't exactly know how to get where I wanted to go. But talking with some of my friends from this Middlebury Elementary School team, they had done what is called the SULI program, or the Science Undergraduate Laboratory Internship Program at NREL, and that's how they got their foot in the door. So next slide, please. So I decided to apply, and last fall, I started as a SULI intern at NREL in the Building Energy Science Group, working on energy efficiency research for new ways to distribute power in buildings. And over the fall, I had a great experience with that. I wasn't entirely sure I wanted to do electrical engineering my whole life, but it was a great experience, and I got the chance to, next slide please, reconnect with the competition manager for the Solar Decathlon, or Race to Zero. And that connection ended up connecting me to another key mentor in my life. And next, please, a senior engineer who worked with the competition manager on an initiative called Smart Labs. And he also happened to be a mountain biker, so we bonded over that. And I went on group rides with them. And at the end of the fall, it ended up that they, both the competition manager and the senior engineer, offered me an opportunity to continue working at NREL. Next slide, please. And next. And this, they wanted support on what was called the Smart Labs Toolkit, and this is through the Department of Energy Federal Energy Management Program, designing a resource for laboratories to be, for designing high-performance laboratories and maintaining them. And I also was supporting the Solar Decathlon Design Challenge. So I was on the backside of a competition that had been such a transformative experience for me. And so over the past year, I continued working on that Solar Decathlon, and I still work on that project now, as well as the Smart Labs. And both these mentors in my life have been key to, one, inspiring me to kind of go above and beyond and really show my strengths that came from that liberal arts physics education, the technical communication that I thought maybe I'll go into engineering and learn all the equations, but you really learn that all along the way, and like the communication and all the different experiences that I've had up to now have all come into play in my projects. So that brings me to where I am now as an energy engineer, and the people I work with are really the favorite part of my job. I am so lucky to work with an inspiring group of engineers who really love what they do, are just a positive community, and have a great work-life balance. They do great, impactful work, but also get outside and enjoy their free time. Also, the variety of projects I get to work on. I am so lucky I never quite could decide exactly what I wanted to do, so I was always involved with a bunch of different activities at any given time, and working at NREL has really allowed me to use that variety and all my diverse skills to use and get involved with a student building design competition, as well as the toolkit, which includes some graphic design aspects, as well as talking to people and encouraging them to include Smart Labs principles into their laboratories. So 2 very high impact projects, which brings me to my last point of the mission and impact of NREL. Our director always says it's our mission to save the world, and I truly believe that the people and the work that we do really has a positive impact, and to know that you're a part of that really brings me to work every day. So that is where I'm at now, and you're probably wondering, well, how do I get there? What can I do to get where I want to go? So I have 3 pieces of advice. Next slide. First is make connections. As Bill said, these connections you make along the way, the mentors you have, they really influence kind of what doors open for you, and they help support you at key decision points. Next slide, please, the little transition. But find good mentors, find people that support you in your decisions, know what you're passionate about, and make these connections. And it's not just getting email addresses and phone numbers and names. It's really making a connection, finding out what those people are interested in. And if you're passionate about the same thing, you can bond over that, and hopefully it'll open doors to move forward in that direction. Next slide, please. Number 2, no experience is a bad experience. So I think what Bill says too, like every experience you go through, you find skills and perspectives that you wouldn't have otherwise had. And even if it's a job that you weren't quite excited about and don't want to stay in forever, you'll learn skills that will come in handy in unexpected ways in the future. Next slide, please. The skills that I learned in all of my experiences so far have come in handy in unexpected ways. Not only the fundamental physics understanding and problem-solving skills that I got through my coursework at Middlebury, but the communication skills and the ability to work on a team, as well as the connections I made through that, all were extremely helpful in guiding me where I needed to be. So say yes to new opportunities. Next slide. And number 3, ask questions and don't be afraid to make mistakes. This is the most important. I think there is a kind of ego out there that you can't make mistakes, you can't ask questions, and you should know everything you need to know in order to do the job you need to do. And that is entirely not true. If you have a passion about something, you will have the go-to to get the things that you need to know, learn more, read more, follow what you're passionate about, and don't be afraid to ask questions, buck the status quo. I love this quote. People willing to buck the status quo and question all the assumptions which have been tutored as best practices for not just years, but decades. So we need people to continue to question what is currently best practice and keep driving us forward. And we're not going to get there unless we make mistakes. So mistakes are a good thing. You learn from them. And especially in this day and age, next slide, please. With unprecedented challenges at every corner, it's easy to get caught up in kind of the bad of the world, but really the cure for depression is action. As long as you do something that you're passionate about and you bring your strengths to the table, you will make the impact and get to where you need to go. So don't worry about over-engineering your career. Just follow your gut, follow your passions, and as long as you keep moving, you'll get to where you need to be and make the impact you want to make. And thank you.
Okay, thank you very much, Amanda, for sharing your story and how you got to where you are today and what has inspired you. And that is just really something to take to heart, and I think for people at any stage, really in their career. So thank you very much. And we're going to hear from one more speaker, but do keep questions in mind that you want to ask when we open it up for Q&A shortly after our final speaker. And speaking of, I'm very happy to introduce Margaret Tam, who graduated in May 2020 from the University of Illinois at Urbana-Champaign with a Bachelor of Science in Agricultural and Biological Engineering with a concentration in renewable energy systems. On campus, she was involved in the University of Illinois Solar Decathlon on the PV photovoltaic and electrical sub-team, where she helped design the 11 kilowatt rooftop array for Adapt House, as their entry was known. And following graduation, Margaret moved to Washington, D.C., where she currently works as a project engineer for Standard Solar, which is a leading solar energy company specializing in the development and financing of solar electric systems nationwide. And with that, I'm pleased to turn the floor over to Margaret. Margaret, over to you.
Thanks, Jonathan. Thank you for that introduction. And I love hearing from Amanda and Bill, so hopefully I can follow them well. So like Jonathan said, my name is Margaret Tam. I just graduated in May, so I'm really fresh in the industry. I graduated from University of Illinois. And just a little background on myself, I grew up in the Chicagoland area, and I grew up vacationing in Michigan in the summers a lot with my family. And I just kind of fell in love with nature and everything that was involved with it. And then I took a earth science class in high school and learned a lot about climate change. And then from then on, I just kind of been really into climate action and green energy and sustainability. And I just figured out from a pretty young age that I wanted to go into something green. I wasn't completely sure what exactly it was, but I knew that that was the path that I wanted to take. Next slide, please. So then going into college, I knew I wanted to do engineering. I liked math and science, but I wasn't completely sure what discipline I wanted to do. But through some good advisors, I was able to settle on the discipline that I went into. So I did agricultural and biological engineering, and I concentrated in renewable energy systems. In addition to a strong engineering base with all the traditional engineering classes, I was able to dive a little bit more into specific classes for renewable energy. And I covered a lot of topics from solar to wind to biofuel to energy economics, and kind of got a broader picture of the green energy as a whole and not just the technical aspect of it, which I thought was really great and beneficial. And then in addition to my degree, I was able to be a part of the Solar Decathlon at U of I. Like Jonathan mentioned, I was on the PV and electrical sub-team. I, myself and a couple other students, designed the rooftop array for our Solar Decathlon Build Challenge House, which was a great experience for me, and I was able to learn a lot more about green buildings and energy efficiency and renewable energy, and kind of bringing all those together to lead to a greener future. That was a great experience for me. Next slide, please. So then following graduation, I did move out to Washington, D.C., and I started working for Standard Solar as a project engineer. So majority of the time today, I'm going to kind of dive into what I do on a day-to-day basis, which hopefully will be beneficial for those listening in. So my primary role is supporting the bid stage design and development for projects for Standard Solar, and most of our projects range from 100 kW megawatts DC, so more like the middle range in terms of the sizing of arrays in the industry. So I primarily do bid drawings, which we call PV1s, which I'll show you a couple. And I create production models using solar modeling software to accurately estimate the production for the systems that we are going to build. So as most of you probably know, the production from solar arrays is very location dependent, depending on where you are, if you have trees around, if there's mountains around, what time of year, if there's a lot of snow. There's multiple things that go into determining how a system will perform, which this software helps us to estimate. And in addition to that, I do use engineering judgment in thinking to optimize layouts and designs to get the most efficient and best performing system that we can, given the certain restraints that we have for each project. And I also work with sales closely to analyze potential sites for solar to figure out if sites that we are looking at really are suitable for solar, or if it might not be the best place to go, and kind of bringing the engineering mindset into the sales realm, which is an interesting place to be for sure. Next slide, please. So this is kind of a lot going on in the first picture, I'm sure, but this is what we call PV1, which is our bid drawing, which is basically just the first design of the system, the first take at it, what we think the system's going to look like, and all of the layouts and everything that's going to go into this system. So before I even begin any of this, I do what I like to call a desktop review. So once we find a site that we're looking into, I'll go in and look for just some certain things about the site that right off the bat may make or break the site. So for example, I'm going to check for wetlands and floodplains, because a lot of times if we're trying to build in those areas, it might make it more difficult or more costly, which might not make the project too feasible. I also check for endangered species and critical habitats, because we don't want to go build in a critical habitat and then harm certain species or harm certain ecosystems, because that's kind of against the whole idea of clean energy and preserving the natural world and everything. So we do try to do a really good job of making sure we're not harming any thing like that. In addition, I do check with the FAA if the proposed location of this array is feasible with them. This is something that I didn't really know about until I started working either, but the FAA, which is the Federal Aviation Administration, kind of likes to know where solar arrays are located, because these panels do have the potential to produce glare, which can be harmful to pilots when they're flying. So it's an important thing to check, because if you're close to airports or places that planes will be flying over a lot, you do need to take that into account. And then after that, I'll just do a general check of the site, see if there's anything else that is needs to be pointed out. So if we take a little bit better look at what the image I'm showing right now, I know it's kind of blurry, I apologize, but you'll see that I've called out a lot of things. One of the things I called out at the bottom array is there is some existing concrete, so maybe this was an old parking lot, or maybe it was an old basketball court or something, but this concrete will need to be removed in order to build this array and make it work. So that's something that definitely should be noted, because it's going to impact the cost and the feasibility. In addition, in the kind of middle array and between the bottom and top one, I do call out areas where we need to clear trees. So unfortunately, sometimes tree clearing is necessary. We try to minimize it at all times, but sometimes a couple trees do need to be cleared, but it's definitely a good thing to note. And then also this array is a little unique in that we're proposing an array next to a baseball field. So we would like to put up some protective netting to kind of protect the array from flying baseballs that could crack the panels or other things like that. And then if you'll also notice at the top left-hand corner, that what we show is this big black circle, which is what we call the POI, which is the point of interconnection, which is very important when you're designing solar arrays, determining where you're going to send this energy, whether it's going to the grid or what we call behind the meter, so connecting into an existing building, which this specific system is. it's really important to point out where this point of interconnection is and what type of interconnection it is, because it will determine a lot of the design requirements going forward. Next slide, please. So once we get through, I get through a lot of that initial site analysis stuff, I'll go more into the nitty-gritty of the design and determining how big the system is and how it's going to be laid out. So if you'll see, this is another example PV1, and you'll see it's a little bit different than the previous one. It's a little bit more rural. There's a lot more space to work with here. So one of the main things that we like to take into account is shading. And as you'll notice, I have shown some trees, which are those weird triangular shaped things, which we use to communicate to the viewer that there are trees here. And the widest part of it is what we would expect the shading profile to be in the winter. So that represents like the worst case scenario when the sun is the lowest in the sky and the shading is the worst. And that's important to communicate in a visual drawing like this so that the viewer can understand where the potential places for shading losses are, in addition to kind of communicating to the viewer why you maybe put the array in a certain spot versus another spot. So if you see from in this example, I tried to avoid certain areas where there would be higher shading. So that's definitely something to take into account. In addition to shading, we also like to, we need to take into account where this is being built in terms of like what state. There is a big variance in legislation and laws in terms of renewable energy. When you go state to state, each state has different restrictions, different interconnection laws. There's a lot of different things to be keeping track of. So that's important to note. So, for example, this site happens to be in Maryland, where the maximum interconnection for a community solar project is 2 megawatts AC, which is important to know when you're designing because that's kind of your cap. And then in addition to that, just a little bit more about what else is called out in this kind of complicated drawing. We do like to take into account what we call the gravel access pathway, which is that long, skinny road going from the array all the way out to the east to the what appears to be a highway. This is important to note as we need to be able to access the array, and some of these arrays are in really rural areas, and access might be limited, so it's important to note that in order to plan ahead. Next,
Margaret, I
slide,
need
please.
to encourage you to move ahead in your slides as we're approaching time, so we have time for questions. Thank you.
Oh, okay, sorry. We can skip this slide. We can go to the next one. Just to quickly go over production modeling, I briefly mentioned in the beginning. So we use a production modeling software called PVSys, which is used widely in the solar industry, and it basically you put a lot of site-specific information into the software, and it helps you determine accurately how much energy you expect your system to get. So we're going to put in what type of modules, what type of inverter we use. On the right side, you'll see this yellow blurb thing, which represents the horizon file, which is the horizon is very important because if you have a skyscraper in the distance or a mountain range, it could really affect the amount of solar insolation that is able to reach your array. Next slide, please. And then to show you just a little bit more pages from a PVSys report, it kind of just shows you the annual production and the specific production ratio, which is essentially a measure of the efficiency of the system. And then on the last page, it just breaks down all the different types of losses you may expect from an array and the amount of energy you should expect at the end. So, you know, that's kind of a lot of information, a lot of technical information being thrown at you, but hopefully you can get a good idea of production modeling and how that plays into solar design. Next slide, please. So, although I really enjoy my job, I enjoy the creativity aspect of it and also the engineering judgment and optimization that I use to optimize systems and make them the most efficient they can be. But although I really enjoy it. I didn't always know this is exactly what I wanted to do. So in order to get here, I did have a lot of good mentors, like Amanda and Bill also mentioned. I was able to have 2 really good internships where I was able to hone in on what exactly I wanted to do within the industry. Exactly, I would like to be like my first job. So my advice for my younger self and students that are listening is primarily to network, to identify people in the industry with jobs you think you might want, or just to learn more and really ask them questions about what they do on a day-to-day basis and what they like and don't like about their job, to really figure out what there is in the industry and what you can do and what you will like. Also join relevant organizations. And then lastly, if you do have the opportunity to have internships, to get involved in as many projects as possible, to broaden, really see what is out there and figure out what you do and do not like, because it will help you in your job search and help you find a job that you like and enjoy doing. So hopefully this was helpful, and any students listening that are entering the industry soon, and hopefully I could be of help to you. Thank you.
Great. Thank you very, very much, Margaret. We really appreciate your presentation and sharing more about you and how you got to where you are. And now is the time for all participants to ask questions of any of our speakers. We have 6 minutes for questions before the top of the hour when we have a hard stop. Do use the functionality on your screen to either chat in a question or virtually raise your hand. And now I'm going to turn things over to my colleague, Tyler, to see what questions have come over the line. Tyler?
Thank you, Jonathan. We had a good question from Emily, which I think would be great for any or all of our panelists to answer. Emily asked do you think the way to switch to clean energy and a healthier environment is through many changes in many areas, such as architecture, type of energy, or use of land? Or are there any big changes that the U.S. could make, such as new policies, that would immediately help?
Yeah, great question. I can start with that. I think we need to affect all different areas. There's not just one, policy, engineering, architecture, all those aspects really add a piece to this puzzle and will provide kind of where we need to go. And use your strengths. So if your strength is in talking to people and policy, go there. That's where you can make the biggest impact. There's not just one answer to this question. I think we need to bring all the perspectives. So any way you can come into it in this industry is great. And I'll pass it off to other panelists if they have feedback.
This is Bill.
Okay, Tyler, if you're speaking, you're on mute, because I think we probably have other questions for our presenters. So, Tyler, what else do we have on the line?
Yeah, if I'm not mistaken, I think Bill was just about to jump in and respond to the last question.
Yeah, just offering that I concur. I think there is no right answer. It's all of the above. I think at the tactical level and the individual, say, building or architectural or even just community engagement level, all the way up to national and international policy, and everything in between, from the technical to education to policy elements, financial industries, et cetera, all have a role to play, and whatever way that you can leverage your skill set accordingly, I think is an important way to engage in this conversation and this career path.
Great, thank you very much. We have another good question from Evan, who asks if you have any recommendations for individuals who don't have much of a STEM background but want to work with systems and or policy design.
I can jump into that as well to start us off. So yeah, I had the chance to, a student design competition is really a great way to jump into that and get involved in an internship. And you can bring your skills to the table. With the Solar Decathlon Design Challenge, for example, we had no knowledge of system design or buildings or anything. We're a ragtag group of liberal arts students from economics to architecture. Didn't really have the technical background, But through that experience, you're able to learn more about the technical side and build out that skill set as well. So experiences like that, there's a lot of student competitions out there to get involved with, so I encourage you to go that route and read, like what Bill said. Learn what you want to learn.
Yeah, thank you very much. Looking at the clock, I do want to be mindful of, we have some outstanding questions, so I don't want to leave our attendees hanging. I will share your questions with our panelists, and you can also get in touch with them at your leisure. Their contact information is in the slides in this deck, and we'll be posting a recording after the fact in a follow-up email to all attendees. But Jonathan, I know we do have a few closing announcements that we'd like to get to, so I will turn it back over to you to lead us out for the day.
Great. Thank you very much, Tyler. Thank you also for the questions, and thank you again to all of our speakers for outstanding presentations and really inspiring in terms of their career trajectory. We want to share a tremendous resource for all on the call. The Department of Energy has a great resource. Go to the URL on your screen. They also have a newsletter you can subscribe to monthly that will give you more information and resources in this area, and they are very dynamic. And we'll move on to our next and last slide and share that for more professionals on the call, there is a tremendous opportunity concerning DOE's what we call a funding opportunity announcement, where there is up to $80 million, not for just one participant, but for the whole program, that you can apply for by November 5th. Go to the URL in the lower part of your screen for more information on that. It's a really great initiative. So with that, I wanted to say thank you to my colleague Tyler. Thank you to all the participants, and thank you again to our really fantastic presentations and all of our speakers on our panel today. We hope you've been inspired, as I know I have been. So with that, that concludes today's virtual session, and we will be back next month with the next in our series. That concludes today's session. Have a great day. Look forward to being in touch next month.